Hi everyone. My project is about improving mathematics education in elementary and middle school. Here, I explore some proven practices that can be implemented in AR/VR in order to improve mathematics education. The key here is proven because that in itself is a huge challenge to identify what practice would work. Fortunately, IES, Institute of Education Sciences, and NCER, National Council for Education Research, has published detailed practice guidelines for handling different issues in education, including improving mathematics education. For this project, I am using these recommendations. For those who are interested, check out What Works Clearinghouse portal to find out more about it. Spatial learning. Spatial learning is identified as a key factor in determining a student's success in STEM education. It is also identified as a challenging skill for some students. Halpern et al. Identified that girls in elementary and middle school tend to have challenges in spatial cognition, which is later exacerbated in engineering and STEM education. Playful learning or discovering learning not only sparks curiosity in young minds, but it also helps students engage in class content more meaningfully. It also helps students to understand abstract mathematical concepts better. Mathematical thinking is particularly important in elementary and middle school. Some examples are child's ability to correlate mathematical terms like addition as an increase in something and subtraction as a decrease in something. Such an understanding strengthens students' learning and retention. Here I have listed how AR/VR supports these types of learnings required for our use case. Spatial learning. In the paper cited, researchers have used AR/VR's unique spatial affordance to explore AR/VR effects on learning on multiple situations, ranging from a virtual lab to a mixed reality enabled museum. Research suggests that AR/VR has positive effects on students' learning with unique opportunities to improve spatial cognition. Playful learning. Researchers also used AR/VR to simulate virtual worlds with real-world problems like air pollution, water pollution, providing students with opportunities to learn about the problem and provide solutions for the same in the virtual world to test. For some researchers have applied the same in teaching high school mathematics and they have reported positive benefits. Mathematical thinking. AR/VR provides unique opportunities for students to visualize mathematical problems or concepts in ways that would otherwise be never possible. Imagine explaining gradient descent of a function with the help of an interactive visualization on a higher order geometry in a virtual world. AR/VR elevates the interactivity by putting the learner in the middle of the whole experience. In this slide, I explored the feasibility of the solution. Bricken's 1991 paper has a convenient framework for educators to gauge a AR/VR solution in general. Cost. Cost is the most important factor here. Most of the elementary and middle school teaching materials can be cost effectively built with classroom materials, but the key consideration here is scale. Can we explore AR/VR solution that can be easily used by educators to build content and can be used at scale? The answer is yes. There are multiple projects available that can simply generate QR codes which can be overlaid on physical objects, which when scanned by a mobile device can create a visualization that can help students learn and engage better with the content. More solutions such as this should be explored since cost is a key factor. Usability. Since AR/VR require a smartphone or computing device, usability will be slightly restricted, especially in poorer neighborhoods where such resources could be scarce. Fear of technology. Historically, HMD has been a subject of such fear. However, mobile devices are quite common these days, so we may not have such issues. But it should be explored further to understand the target audience and their perception of technology. The next milestone, I'm planning to build a Hello app in AR/VR using the industry tools and report how easy or difficult it is to build one. I'm planning to use Unity with the R core or Unreal with the AR core, since the combination can cater to most commonly used mobile devices. Besides that, they also have a huge community knowledge and support that I can use. I will also explore other cheaper and easier options that can be really helpful to educators. In the next milestone, I will come up with simple use cases that make use of the above mentioned affordances and try to develop the same in the sample app. I will also look for other studies which analyze such use cases and report the findings. I will also explore how content is being created in the AR/VR industry now and find out if it can be simplified so that educators can create their own content in a democratized platform. That's it from me now. Let me know your feedback so that I can improve on the next milestone. Thank you.